Hi friends, how are you? So in this time I discuss about class 12 physics, dual nature of radiation and matter. It is very most important topic. Okay. So in this time I discuss about summary and points and ponders. Okay. So first you understand summary. Okay. The minimum energy needed by an electrons to come out from a matter surface is called the work functions of the matter. Energy greater than the work function phi naught required for electrons emissions from the matter surface can be supplied by suitably heating or applying storage electric field or irradiationing. Okay, it's by light of suitable frequency. Next topic, photoelectric effect is the phenomenon of emissions of electrons by matters when illuminated by light of suitable frequency. Certain matters respond to ultraviolet light, while others are sensitive events to the visible light. Photoelectric effect involves conversions of light energy into electrical energy. It follows the law of conservation of energy. The photoelectric emission is an instantaneous process and possesses certain special features. Photoelectric current depends on I. The incidentally the instantly of incident light to the potential difference applied between the two electrode and 3 the nature of the emitter materials. The stopping potential V naught depends on 1 the frequency of incident light, and 2 the nature of the emitter materials. For a given frequency of incident light, it is independent of its intensity. The stopping potential is directly related to the maximum kinetic energy of electrons emitted. E v naught is equal to half of m v square max is equal to k max. Below a certain frequency, there hold frequency V naught characteristics of the matter. No photoelectric emission takes place, no matter how large the intensity may be. The classical wave theory could not explain the main features of photoelectric effect. Its picture of continuous absorptions of energy from radiation could not explain the independence of Kmax of an intensity, the existence of V naught, and the instantaneous matter of the process. Einstein explained these features of the basics of the photon picture of light. According to this, light is composed of discrete packets of energy called quanta or photons. Each photon carries on energy E is equal to h mu and momentum p is equal to h by lambda. Okay, which depends on the frequency v mu of incident light and not on its intensity. Photoelectric emissions from the matter surface occurs due to absorption of a photons by an electrons. Next topic, Einstein's photoelectric equation is in accordance with the energy conservation law applied to the photon absorptions by an electrons in the matter. The maximum kinetic energy half mv square max is equal to the photon energy h mu minus the work functions phi naught is equal to h v mu naught of the largent metal. Target metals half m v square max is equal to v naught e is equal to h mu minus phi naught is equal to h v minus v naught. The photoelectric equation explains all the features of the photoelectric effect. Mulliken's first precise measurement confirmed the Einstein's photoelectric equations and obtained an Walker's accurate value of Planck's constant H 6.63 into 10 to the power minus 34 joule per second Planck constant value. This led to the acceptance of particles or photons descriptions nature of electromagnetic radiations introduced by Einstein. Radiations has dual nature, wave and particles. The nature of experiment determines whether a wave or particles descriptions is best suited for understanding the experimental result, reasoning that radiations and matter should be symmetrical in nature. Louis Victor de Broglie attributed of wave like characters to materials particles. The wave associated with the moving materials particles are called matter waves or de Broglie wave. The de Broglie wavelength lambda associated with the moving particles is related to its momentum p. Lambda is equal to h by p. Lambda means wavelength, h means Planck constant, p means momentum. Momentum is equal to mass into velocity. The dualism of matters is inheritance in the de Broglie radiation, which contains wave concept lambda and a participles concept p. The de Broglie wavelength is independent of the change of the charge and matter of the material particles. It is significantly measurable of the order of the atomic place spacing in crystals only is in case of subatomic particles like electrons, photons, etc. due to smallness of their masses and hence momenta. However, it is indeed very small, quite beyond measurement. In case of microscopic object commonly uncountable in everyday life, electrons diffractions experiments by deviations and German by GP theorem, as well as many later experiments have verified and confirmed the wave nature of electrons. The de Broglie hypothesis of matter waves supports the Bohr's concept of stationary orbits. Next, you understand physical quantity, symbol and dimensions, unit and remarks. First, Planck constant H, dimension m L square T inverse 1, unit joule second, remarks E is equal to H mu or V. Next, stopping potential V naught m L square T inverse 3 A inverse 1, unit volt E V naught is equal to K max. Work function phi naught m L square T inverse 2 joule electron volt. K max is equal to E minus phi naught. Next topic, threshold frequency V naught T inverse 1 Hz hertz. V naught is equal to phi naught by H. De Broglie wavelength lambda L meter, lambda is equal to H by P. Next I discuss about points to ponder. Free electrons in a matter, the free in the sense that they move inside the material in a constant potential. This is only a approximations. They are not free to move out of the metal. They need additional energy to get out of the matter. Metal. Free electrons in a metals do not allow have the same energy like molecules in a gas jar. The electrons have a certain energy disruptions at a given temperature. Distributions in is different from the usual Maxwell disruptions that you have learned in the study of kinetic theory of gases. You will learn about in it in later courses, but the difference has to be but the difference has to do with the fact that electrons obey Pauli's exclusion principle. Because of the energy disruptions of free electrons in a metals, the energy of required by an electrons to come out of the metals is different for different electrons. Electrons with a higher energy required less additional energy to come out of the metals that those with lower energies. Work functions is the least energy required by an electrons to come out of the metal. Observations of photoelectric effect imply that in the events of matter light interactions absorptions of energy takes place in discrete units of h mu. This is not quite the same as saying that light consists of particles each of energy have. Observations on the stopping potential, its independence of intensity and dependence on frequency are the curical discriminators between the wave picture and photon picture of photoelectric effect. The wavelength of a matter wave given by lambda is equal to h by p. P means momentum, lambda means wavelength, h means Planck constant, has physical significance. Its phase velocity Vp has no physical significance. However, the group velocity of the matter wave is physically many many meaningful and equals the velocity of the particles. Okay, so thank you. Dual nature of radiation and matter, I completed this chapter. Next I discuss about very most important topic, atoms. It is very most important topic. Thank you, take care, goodbye.